Some of the chemical ingredients later used by life may be older than our planet. Astronomers have detected the first true sugar molecule in interstellar space, erythrulose, floating in a molecular cloud near the center of the Milky Way galaxy. It is not evidence of alien. It is evidence that the universe can prepare surprisingly complex prebiotic chemistry before a planet is born. Erythrulose is a chiron 4-carbon ketose. In ordinary language, it is a relatively simple sugar molecule with 4 carbon atoms. Researchers detected it in a cold, chemically rich molecular cloud known as G plus 0.693 minus 0.027. Yes, that's the name of that molecular cloud, roughly 27,000 light years away in the region of the galactic center. This is not a planet and not a living environment. It is a huge cloud of gas and dust where molecules form, collide, and sometimes freeze onto microscopic dust grains. The discovery matters because sugars are central to biology. They are used in metabolism, energy storage, cellular structures, and the backbones of nucleic acids like deoxyribonucleic acid or DNA. Astronomers did not bring back a sample. They used 2 radio telescopes named Yebus 40-meter and IRAM 30-meter to search for erythrulose's rotational spectrum, which is its molecular fingerprint at radio frequencies. Every molecule can rotate only in certain ways. Those rotations produce a characteristic pattern of spectral lines. Researchers first measure that pattern in laboratory, then look for the same set of frequencies in space. The team identified 12 groups of lines corresponding to 17 erythrulose transitions. 6 of the strongest groups were relatively free from interference by other molecules. Scientists behind this project estimated the chance alignment probability for these 6 lines at about 0.2%, providing strong support for the identification. Erythrulose also appeared to be at least 8 times more abundant than comparable 3-carbon sugars that were not detected in the same survey. Chemical models suggest a reason. Erythrulose may form efficiently on icy interstellar dust grains when simpler 2-carbon molecules react together. Shocks moving through the cloud can then release some of it into the gas, where a radio telescope can detect it. That means fairly complex sugar chemistry may begin inside the raw material from which stars, comets, and planets eventually form. Under watery conditions, erythrulose can rearrange into a related sugar called therulose. Therulose is interesting because scientists have built therulose nucleic acid, or TNA, in the laboratory. TNA is a simpler relative of RNA that has been discussed as one possible component of pre-RNA chemistry. This does not mean erythrulose create the first genetic system. It means interstellar chemistry could provide sugar feedstock that later participates in many possible reactions. Meteorites and asteroid samples already show that organic molecules can be delivered to young planets. This discovery pushes part of that chemical history back to the interstellar cloud. The study did not find life. It did not find DNA or RNA in interstellar space. It did not show that these molecules reached early Earth or that they inevitably produce biology wherever they arrive. Life requires more than ingredients. It requires organization, energy, a suitable environment, and a pathway from chemistry to evolution. The universe may not assemble living systems between stars, but it may begin stocking the laboratory before planet exists. For more science without the hype, subscribe to my channel of Science and Other Demons.